All right. So, oh, I need Sean. Sean. How do I get hold of Sean? Sean Miller. No longer here. All right. Let's just say, Aiden. Aiden's not gonna run as fast as Tyler. So let's just assume that he can run like this. And this is just a very interesting graph. I'm just gonna draw the straight line here because okay, so this is a velocity graph, V of t, and each one is mile per hour. So 1, 2, 3, 4, 5. And this is in term of mile per hour. And this is the time is gonna be hour. So we're gonna just do something basic. We're not doing something fancy. So let's assume that Aiden can run like 6 hours. He's David Goggin. The next, run until you break your feet. I don't know how that guy does it, but how do you run until your feet broke? I'll be crying before my feet broke. Yeah, that's crazy. So let's just say first 3 hours, right? Easy. 5 mile per hour, 15 mile. That's like it. Okay. 15 mile. That's like. Can you do 15 mile? No.
Yeah.
15 mile?
Yeah.
No. 15 mile?
Oh, wait, no.
Can you run in 3 hours, 15 mile?
I've done a half marathon.
Half marathon? How much is half marathon? 11 miles.
No, 13.1, I think.
Oh, 13.1 miles? How long it take you?
55 or something.
Oh, 2 hours. Oh, okay. I cannot run. No, if you see me pass out in half hour mark on the road, I'm done. I cannot do this. Somebody come carry me, wheelchair me.
Yeah, no, I saw that. I was like, it's a very questionable shape, isn't it? Yeah, it is. You probably changed that.
All right, so let's just say first 3 hour. How much distance can you cover the first 3 hours?
15 miles.
It's gonna be 15 miles. Can you tell me what's that in terms of calculus here? Can you see where's the 15 come from? Which is what?
The area of the positive velocity.
The area of the positive velocity. Thank you. So it's gonna be this area right here, right? And there's actually 3 hour, and there's actually 5 mile per hour, and this is a 3 hour. And if you times each other with dimension analysis, guess what? The hour cancel out, and that's 5 times 3 is equal to 15, right? 15 miles. And we know that. That's how much distance you cover. So area under the curve is the displacement. Displacement. Okay, so now it comes the next thing. The next thing is, hey, do you know what's the difference between total displacement versus total distance? So let's say in 6 hours. So in 6 hours, what will be my total displacement? And what will be my total distance?
Is it negative 5 on the bottom?
Huh?
Like when you go down, is
I
it
think it's negative 6.
negative 6? Oh.
Yeah. 1, 2, 3, 4, 5, 6, 7. Okay. What will be the total distance and total displacement. So can somebody tell me that and why that is? And we can come up with a formula. I know Ethan knows. I know Ethan probably knows. I'm gonna ask somebody that I usually don't ask, which is Jack. What do you think? Do you take physics? Ooh. Oof. Or what you guys call it? Oof. I don't know what's that word mean. Oof.
Roblox. Roblox definitely.
Roblox sound. It's not Minecraft.
No.
It kind of was, yeah.
I don't Minecraft has that sound too.
It's a lower.
Lower pitch.
It was kind of like that. And now it's kind of like a slapping sound.
Okay, okay. All right. That's interesting. Okay, total displacement in 6 hours. So, Jack, what do you think? -3. Anybody have different answer? Chase, what do you think?
I think it's
It's okay.
no, 0.
0? Okay, possibly. Corbin, what do you think?
I put -3.
You put -3.
Specifically miles.
Elaine, what do you think?
Displacement.
You've been yelled at green wall one too many times. I'm putting your
Yes. No. I
Oh, no, positive 30.
Positive 3? Okay, Madeline, you're not sure? Okay. Maddie, what do you think? Catherine? Okay, so let's talk about displacement, right? So I'm gonna shade this color. I'm gonna shade it a positive as blue. So they are 15 here, right? But there is a red here, which is. So that means Aiden is running 15, is running like 15 this way. So 15 this way, and it's running back. How many more? 18. So -18. So the total displacement is -3. So he's running past by his original positions because this is a positive area and this is a negative, but it's below x-axis. So they actually counter each other, right? So you're running positive and running 18 backwards. And this is the 18, which is area under the curve. You're running negative velocity means you're running opposite directions. When did I change direction?
There's a T equals 3 hours.
T equal to 3 hours. Now, what's the maximum speed Aiden run?
5 miles per hour. No, 6 miles per hour.
Did everybody understand why it's 6?
You just ran 6 miles per hour in the opposite direction.
In the opposite direction, but speed doesn't matter which direction you run at.
Velocity.
Velocity does. So that's why they call it velocity is a vector. Speed is a magnitude. In physics, you learn that velocity is a vector base and speed is a magnitude. So let's define that in calculus. What will be speed in terms of velocity? It's equal to absolute value of v of t, right? Is that okay? Now velocity is equal to v of t. Now, this is not any kind of velocity. This is actually known as instantaneous. Velocity. That means that velocity at that time. Now, can you tell me what's the velocity at this moment?
5 miles per hour.
5 miles per hour. But what's my acceleration?
0.
0. He's running like a machine. He knows exactly how fast he gotta run. 5 miles per hour for 3 hours. It's like a freaking machine, just 5 miles per hour. He never changes pace. Like one of those robots. Yeah. I don't know. I see a Black Mirror. Have you guys seen Black Mirror? It's an interesting show. But in the future, they just hire those robot dog that to kill you. It's like pretty cool.
Oh, that's another episode.
Isn't that episode? It's so messed up. I cannot watch too many episodes of Black Mirror at once.
It's not good for the soul.
It's really bad.
Do you get nightmares, Mr. Yang?
No, it's just so depressing. But it's so addicting, but it's depressing. Like life's.
Did you watch the episode where like that mom implanted something in that daughter's brain?
Oh yeah,
It's messed up.
that's pretty messed up. Yeah, that's pretty crazy.
Okay.
Anyway, don't. I don't know. I don't recommend that show, but it's interesting. They have offer interesting perspective. Um,
It's inside of my house.
Mr. Yang.
what?
Kelly is inside of my house.
Why is she in your house?
Okay, what is the total distance here, though? What's the total distance?
33 miles.
What is it?
33 miles.
33. Why is 33? Because you have to take account into the negative area, and that is going to be absolute value. So what will be the equation for total distance? So total displacement. What will be the equation for total displacement in terms of calculus?
The integral
Of what?
dt.
B of t dt between A to B. Is that okay? How about total distance? Good. Is equal between A to B of absolute value B of t dt. Is that okay? Something very straightforward, right? Simon's not here again. Now, the slope of this line of velocity graph is equal to acceleration. Well, that gave me in some ideas about things. What kind of idea I'm gonna give you? The relationship between positions is equal to s of t. How do I get to velocity? Velocity is the derivative. Good. So it'll be d to the dt, right? If you take derivative, it goes into velocity. You talk about that in the first kinematic test when we're doing projectile. How about acceleration? It's a of t, so that's going to be what? D to the dt, right? If I take a derivative. Now this is also known as s prime of t. And this is also known as s double prime of t or v prime of t. So they are the same thing. Now how do I go up from acceleration? Integration. So it's going to be integration. And how do I go up? Integration. Right, so I can actually go in from acceleration to velocity, velocity to positions. Those are very, very important things. Am I going too fast? No. Okay. Let's talk about what's average. So this is actually instantaneous. So this is instantaneous. Velocity. Okay, so what is the average velocity? So if position function is given, what will be the average velocity if position function given? That's s of t. How do I find average velocity? What is it?
Y2 minus Y1.
Yeah, I don't like y2 minus y1, but it's a good idea though. A position function is giving, so let's just say s of t is giving. So how do I find average? How do I find average velocity?
You do X equals 2. And then T2 minus T1.
Okay, so instead of 2 and 1,
ds over dt.
no, is equal to changing of s over changing of t, right? Changing of position over changing of time. Let's just say if I have, right now I'm at 0, this is in Orlando, and 2 hours later I'm in Gainesville. So it'd be the changing distance is 100 miles. From here to Gainesville is 100 miles. The changing of time is 2 hours. So my average velocity going to Gainesville is 50 miles per hour. Sometimes you're going to drive 60, but sometimes you're going to drive 40. And you average up to be 50. So that's called average velocity. So that is a changing position of a changing time. It's going to be SB minus S of A over B minus A. You have to know all your equation today for your homework. Because calculation is up to you. Questions? What? It's 2 different times. So like say right now I'm at time 0 and 2 hours later I'm at Gainesville. So the t difference is going to be 0 and 2, so it'll be 2. And the position difference right now is 0, but 2 hours later I'm 100 miles. So it'll be 100 divided by 2. That's your average velocity. Yes.
What's the it says S of t equal find the what is that mean?
Average velocity. How do I find my average velocity? It's going to be S of B minus S of A over B minus A. What if velocity is given? What if I didn't give you positions? Velocity is given. What will be the average velocity? Tony, what are you doing? You didn't do homework and you're playing with your phone.
Is it just V minus VA over 2 or no?
That was a major misconception. That's wrong, but that's what everybody does, but it's not.
It would be like V of B minus V of A and then the derivative of 1.
That's what Ethan say, but that's wrong. How do you find velocity? How do you find if velocity is given? How do you find average velocity?
You integrate it and then do that.
Somebody is on a good track. So he says integrate V of t. Why do you integrate V of t? To get S of t. But you know it's S of B minus S A over B minus A. So what else I'm missing? What else I'm missing? What is it? The 1 over what? 1 over B minus A. Good. Does that remind you of something? What is this called?
Average value.
Average value? Right? Or in this case, it's average velocity. Because if you think about it, if I just do 1 over B minus A, and if I just integrate V of t between V of V or V of A, so that's going to be S of B or S of t, have an upper bound between B and A, so that will be S of B minus S of A over B minus A, which is also known as an average velocity. Because in the test question, I can give you a velocity function, ask you find the average velocity, then you have to integrate it, right, when you do that. Got it? So we know how to find acceleration. Okay. How do I find when particle change direction? So if I have a particle change direction is where? Change direction. V of t equal to 0 is actually not change direction, but it could be. So V of t equal to 0 is particle at rest. So it's just resting. It's not moving. It's not moving forward or not moving backwards.
It's when it switches from negative to positive or positive to negative.
Yeah.
I don't know if there's
So
a
change
specific
direction, this is equal to this, but change direction is going to be V of t changing sign. Change sign. But you still find out V of t equal to 0 and see you do a number line, are they changing left and right? Now, if V of t is positive, that means the particle is going right. Right. V of t is negative, the particle is going left. Is that okay? Very, very intuitive. They're not something complex. It changed sign. It changing from positive to negative. So from positive to negative or negative to positive. So it changes sign. If it changes sign, but you're still looking for VOT equal to 0 and do a normal line test, see are they testing. Okay, lastly, we also need to know what the average acceleration is. What is the average acceleration? If we know what's the average velocity, what do you think average acceleration is?
B.
V of t minus v of a.
Yep. So it's changing a velocity over changing time, which is kind of makes sense. If I plus the gas, my average acceleration is going to change because my velocity changed, right? I went from 40 mile per hour to 60 mile per hour. That's accelerating. So you want to see how much velocity change. That means that's divided by time. Am I going too fast? Okay. Lastly, if you have one more thing, speeding up versus slowing down. So let's just say we're gonna create a running chart for Aiden, sorry. And we're gonna have something like this. It's running to 3 miles per hour. Very slow. He's just jogging. It's walking. Can you walk 3 miles an hour? Right? I'm gonna pass out.
Your legs.
Okay, and then it's gonna
And this is velocity.
this is a velocity graph, and this is time. Okay, let me ask you, Catherine, what's maximum velocity here? No, what's the maximum speed?
3 miles.
Maximum speed? Think again. Maximum speed. It's okay. Try again. It's not 6. Count again. Men?
5.
5. Can you tell her why it's 5?
So speed is absolute value of the greatest like value on the y-axis, so you just count down 5. So like the maximum speed would be.
This is 3. This velocity is 3. This is -5, but speed is absolute value of that, so it's +5. So you're looking for how far the distance from the x-axis. The more further, the higher the maximum speed is. Does that make sense? When did the particle change direction? When did Aiden change direction?
Six.
Equal to 6 because it went from positive to negative. Good. Good. Can you find total distance and total displacement here? So we can find a lot of things. Maximum speed is equal to 6 miles per hour. And we can say particle change direction. At t equal to 6. 6 hour. What will be the total distance? Total distance and total displacement.
Wait, the speed is 6 miles per hour? The fastest speed?
It's 5. I can't count, sorry. What will be total displacement and total distance? What will be total distance? 32? I don't know. 42? You count them? So this is 6 plus 2 divided by 2 times the height. So that is equal to 18 over, 8 over 2 is 4. This is 12. And this is 1, 2, 3, 4, 5, 6, 7. 7 plus 2 divided by 2 times by 1, 2, 3, 4, 5. So it's 9 over 2 times 5, I think. So 45 over 2. So that's 22.5. 34.5. Is that right? 7 plus 2 divided by 2 times the height is 5. Yeah, that's right. So it's gonna be 22.5. 22 is 34.5. So 34.5. What will be the total displacement? Let's put the phone down. Why are you guys using your phone?
21.5.
Huh?
21.5. A negative 21.5. Sorry.
Negative 21.5. It was 12 minus 22.5. Right?
24.5. 12 minus 24.5.
No, it's 22.5. It's negative 10.5.
Sorry, my brain looked at the number on the side. Saw 34.5 and was like, oh yes, this is the number.
Does that make sense?
Yes.
Okay. What is the acceleration at t equal to 1? What's the acceleration at t equal to 1? What is acceleration at t equal to 1 here? What's a of 1? 3 over 2. Why? Slope. It's acceleration is the slope of velocity, right? How much time I have?
6 minutes.
Okay, so we're gonna talk about speeding up and slowing down. So speed up versus slow down. Okay, so speeding up. We're gonna give an example. Let's kind of show you what happened, right? So let's just say if I have situations here, and okay, this is a stop sign, and I am going to this direction is positive. Is that okay? And I just say, Rajat has a date.
Wait, what?
Okay, so it's positive, right? So, but I see a stop sign. What?
Why are you going to Raj's State?
No, Rajat has a date. I'm a Rajat. I pretend I'm Rajat.
Oh, okay, I see.
Okay, anyway, so let's just say I'm gonna assign that this is positive direction, right? So if I see the stop sign, do I press the brake or do I press accelerate?
Press the brake.
What do you mean accelerate?
I know how to drive.
Oh, clearly. You don't speed up at a stop sign.
Wait, I'm telling you, the brake pedal doesn't
Have you
matter.
ever heard of no cop, no stop? That is a much more important.
Okay, how about this? Imagine that you're Superman and there's a child over there. What will happen? I have a positive velocity, right? Now, what does Superman have to do? Go in front of the car, push the car this way, right? So my accelerating is backwards. So I'm slowing down and hopefully I don't hit the child. Is that okay? So that means velocity and acceleration are opposite signs. Is that okay? So that's how you slow down. Now after the stop sign, of course you can say I'm going to go to Dave. So my velocity is going this way, and I'm pressing the gas. We're going this way. So true positive. So true positive is speeding up. Positive and negative slowing down. Does that make sense? Is that okay? Now going backwards a little bit different. Going backwards is I'm going this way. My velocity is negative or positive?
Negative.
Negative. When I see my stop sign is gonna be positive and negative, my acceleration. It's gonna go this way. Because the Superman had to push this way, right? So they have
I'm
different
trying to run
signs.
over check them.
One eye, so purpose. So if you have velocity and acceleration a different sign, you're slowing down. Is that okay? And after the stop sign, my velocity is negative, my acceleration is negative. So therefore I'm speeding up. Elaine looked at me like I'm weird. Follow me?
No, I mean, I followed you until you went backward.
Okay, backwards. Because my orientation are different. My velocity is going to be going back, which is negative, right? But think about it, the children right here. What does Superman have to do? Yet, if I see the children right on the stop sign, then Superman had to stop the car, right? So guess what? The Superman has to push this way. My acceleration has to be the opposite direction. So that's how I slow down when I see the kid. Is that okay?
Yeah.
Or when I see the stop sign?
Yeah.
Because they are opposite direction. But your velocity is negative, acceleration is this way. Because our acceleration also has direction. So if they have a different sign, you're slowing down. So velocity and acceleration, if they are opposite from each other, then you are slowing down. If they are the same sign, you're speeding up. Is that okay?
Yeah.
Okay. So let's look at this graph. In which region I'm slowing down? In which region I'm slowing down?
T equals 4 to 6.
4 to 6. Why?
Negative.
Slope is negative. Slope is
Velocity.
less than 0, right? But the output velocity is what? Positive. Slope of velocity graph is A of t. So A of t and V of t are opposite to each other. So in this region are slowing down. And 12 to 14, which is right here, because 12 to 14 here, because my acceleration is what? Positive, right? But my velocity is what?
Negative.
It's negative. So they have opposite sign, they are slowing down. Which part is speeding up? Well, this region is speeding up because slope is positive, velocity is positive.
And then you would be going
For this part, velocity is negative, acceleration is negative. Got it? All right, see you tomorrow.
You're going to the bathroom. They can't touch you.
Yeah. You know, I understand that the journey has some interesting driving techniques. I will not be using these.
Happy birthday, Jake.
Hola, buenos días. Bye.
I didn't know it.
Bye, Elaine.
Bro, I came in and the grandma's like, I'm not here.
Kelly, don't touch my computer. My setup is wrong this morning. I cannot stream this morning. I don't know what you guys did. Yeah, you did.
All I did was go live and then I clicked not. That's literally all I did. I swear I didn't touch anything else.
She wanted to embrace the whole thing.
Because you were playing basketball. Yeah, you know
I had to yell at Leah this morning.
I didn't mess with anything other than literally just clicking go live and then end live. That's literally Nothing else. Bro, Chase. I can't believe I actually just said it.